Hello and welcome to Fireside Chat number 49. I am Mash and I am accompanied by Sandro and José as usual. With the three of us are managing directors for Codurance. And the format of this podcast or live stream is basically that we usually pick a subject often related to our work. We are a software consultancy and we have a lot of opinions on the area. A lot of them are ill-formed and ill-advised and not researched, but we talk a lot about this, and through that conversation, we often learn from each other, and we decided that it'll be good to involve others as well. So we do this as a live stream. So people are welcome to join us on YouTube. In particular, we have it live on LinkedIn and Twitter Spaces as well. But if you want to comment and for us to reply back to you and so on, then usually YouTube is better. But of course, it's available on our YouTube channel, so you can listen to it at any time. It's also available as a podcast, and you can also go to codurance.com and you can find these as well, links to them as well. So um, without further ado, the topic for today is essential versus accidental complexity, or why is our software so complex? And we think that the essential and accidental complexity is a very good way to frame this conversation, right? So let's get started. So who's going to first of all define what accidental and essential complexity is as source of complex software?
Ouch, we picked the guy that usually does the definition for us
Yeah,
to open the episode now.
the
So now
definition
we
guy
have
is
to.
you.
I would have done such a good job as well.
By the way, I have the cat here with me, so if you hear meowing or whatever, that's that's right. So, okay, so I'll venture it. Yeah. So, essential complexity is the complexity that you get from that is inherent to the problem that you're trying to solve, right? Like in order to solve that problem you need to do certain steps, yeah, and it can be simpler than whatever steps you have, right? So that complexity inherent to the problem is what I would, well, I know, but you would call essential complexity. Now accidental complexity is anything else that we add to that, right? Like it's basically as we're trying to solve the problem sometimes, knowingly or not, yeah, we introduce, let's call it, more steps or more things that are necessary in order to solve the problem, and that's when we increase the complexity of what we're doing. Yeah, and this could be, I don't know, selecting a different stack or architectural decision or design principle or programming paradigm, whatever it is that you choose, no, in order that the tools, let's say, or the approach that you follow to solve the problem may introduce a lot of that stuff. Yeah. And I think to go now to the question, or Sandro, if you want to add anything else, just
No,
let me
no.
know. But in order to go then to the question of why something software so complex, uh, I would say that uh, is not as easy as it seems not to introduce accidental complexity, right? It is inherently a communication problem. For me, building software is a bit like a Chinese whispers kind of thing, right? It's like whoever has the ideas is trying to tell someone else what they need. Then I don't know, you're trying to tell your team what it is that we need to build, and then they are trying to tell each other how they can do this, and then someone is trying to tell the computers no. So overall it's like everyone is trying to communicate into different levels of understanding of the problem, and that in itself creates problems, right? Because you may not have a shared understanding of what that simple essential problem is, no? And that creates a lot of issues. I don't know, do you have any other
I,
sources or
I
anything
I
you can?
have I have actually a slightly different definition as well, which may be a kind of just another one that adds to it. I think it's not contrary. Before we go into the problem of the communication problem, because
Mhm.
the way I would describe uh, and essential complexity, I think you can describe it from a value perspective as well, right? Essential complexity is if you simplify, the value is reduced, the value that you're trying to deliver. And accidental complexity is where you can simplify without reducing the value. And I'll tell you why I like that
Okay, yeah.
definition.
Explain that a little bit better. I'm still trying to digest what you said.
So basically, you've got, like, you're trying to create some value, yeah. And I'll give you an
Mhm.
example later on that actually Christopher Alexander gave, because it just came to my mind. You're trying to create some value, yeah, and you need to do certain things in order to create that value, yeah. You can simplify your how you create that value by actually reducing the kind of value or the impact that it has, yeah. So the value that you are delivering to business, to whatever, right? So if you simplify and you reduce the value, what you are trying to do is reducing what is essential, because you should not be reducing the value that you are delivering. Whereas if you can simplify the solution without reducing the value, then what you're doing is you're working on simplifying the accidental complexity, right?
Okay. I get it
Now,
now.
and the Christopher, the reason I bring it, because it takes you to one level higher than the solution. It takes you to problem selection, right? So problem selection is the first part of problem solution. Which problem you are trying to solve actually allows you to reduce complexity. So you can, if you don't select the right problem to solve, you're already introducing accidental complexity. And Christopher Alexander, he doesn't talk about it in this way, but his example comes to my mind, and I've described it before as well. He takes this idea of, the value is that you want hot water for your tea, right? Your solution could be a kettle, or your solution could be a tap that produces hot water. They are very, very different solutions. But basically what you've done is, he takes two things: context and form. Context is the problem domain and form is the solution. And where you divide what is context and what is form, what is the problem and what is the solution, can allow you to think of solutions in totally different dimensions, right? And so when you selecting the right problem can mean that you have a very easy problem to solve, or you have a very complex problem to solve.
Is it selecting the problem or selecting the solution?
So it's actually so problem selection. So you've got a in so the way that you think about it, you think value, something that you're trying to solve, like the whole environment that includes both the problem and the solution, right? So that context side of things. So it maybe I'm describing, maybe it's not selecting the problem, but it's what you choose as the environment for your problem, maybe a better way of describing it, right?
Mhm.
So in a way it is a bit for problem selection. It's when you are trying to choose the context, you are shaping the problem, you're framing that problem, right? So you're defining that
Uh,
problem. So I mean, if you
mhm.
think of, like, say for example, is it a problem that I need hot water for my tea? Is that the problem? Or is the problem that I need to find a way to get the hot water? I need the hot water for my tea is is the value. I need to find a way to get the hot water is the problem. And then you've got the solution on how to build that way. That's what I
And
what
is
I
it see? And is it like a way to? I'm just trying to build on the metaphor here. Uh, you could potentially simplify the problem as well, reducing variables or changing variables. Because, for example, you mentioned like I want hot water to my tea, but we didn't specify how fast do we want that. So, for example, can I wait for a few minutes, or do I want that instant? Because also that would lead us, depending
That's
of the
that's part of
different.
your problem selection, exactly.
Right,
You, at the end, you're
I
still
see.
getting your tea. So that's what I mean by
Uh-huh,
problem selection. Yeah, is
I
that
see.
you're still getting that value, but which problem are you trying to solve? And so you starts the simplification process starts at the problem selection part.
So
and
you
then
are
it
trying to,
carries on into the solution part.
so basically, like, just for me to phrase that in a way that I understand better, is like, starting from trying to simplify the problem itself before you discuss the solutions.
If
Yeah.
I may, so I don't think selection may be the right word here. Like definition, maybe I will find more accurate to what
It's
you're
Yeah, I mean, you
explaining.
can call it definition as well. I'm actually taking this term of problem selection from the book by Richard Sennett called The Craftsman. He
Mm.
talks a lot about problem selection as exactly. I mean, you can call it problem definition, problem refinement, all those things. But at the end of the day, when you are refining, you kind of choosing certain areas to be more important than others. When you're refining, or problem analysis as well, you can call it, right? Uh,
Yeah.
but that doesn't mean that other way of solving that or other problem kind of, if you have a bunch of options for a to to or bunch of problems to select, that doesn't mean the others are irrelevant. It's just that you are selecting one area, one way to solve it. And and
Yeah.
this is actually very important, because actually the reason I thought it's worth mentioning is, Sandro, when you were talking to one of our internal teams around speaking to the customer and having a very clear view on, first of all, because the customer often has a selected problem, but they also have a value in mind. And you then
Mhm.
going ahead without really doing problem analysis, you do solution analysis, and that's not where you need to be. You need to do problem analysis and find other ways of satisfying the same value that will simplify the problem and consequently further simplify the solution.
Yeah. 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 This
Sorry,
is
I'm
this is
taking it a
why.
bit too abstract. Maybe we can
No,
go
no,
No,
deeper
no, no, no,
that's
if
no,
you
no.
fine.
want.
That's fine.
It's fine. It's fine
The,
because this actually I don't know. Sandra don't want to know, but it's
no, no, go on, go
actually
on.
we were at some point. No, well, while we were trying to pick the topic and so on, we were talking about kinefin and this framework for dealing with different contexts. And I think that I mentioned like that you can build software in any of those contexts depending on what context you have. You'll be able to refine a bit more the problem or select a bit better what it is that you want to pay attention to. And I think that drives a lot of how you would do things, right? Like if there's a working in an environment where things are clear and simple and so on, you classify, no, and this is this type of problem, there's a very well known solution, you just implement, etc., right? Whereas you work as a startup, you don't even know what what problem you're trying to solve in many cases, etc. You're still trying to figure that out. Your approach will be different, right? Like you will put stuff out, then learn from that, and then try to figure out. And those two things, like how you choose to approach that and what context you're building the software in, factors into that problem selection that you're talking about.
I
Right?
think that
It's
Because,
in it's
maybe a
inherent
slightly
that
orthogonal
context.
concept, to be honest, in Cynefin, because you got chaos and complex and so on, and how
Mhm.
you apply a particular solution to it. Maybe it's a bit orthogonal to that, because for example, in the case of a startup, it's not just about problem selection. It's more about experimentation. You are actually providing some kind of value, and you're seeing that. I mean, at a different level, it is, but not from a solution perspective, more from a product perspective, or more from a
But your
value kind of
solution, and this
perspective.
is this is one of the things. So how your processes are also part of your solution.
Yeah, yeah. I mean, if you
Yeah.
take it at
So
that point where you're where you are making a hypothesis and saying this thing can have value, and you're doing it in a very rudimentary way, for example, like fake it till you make it type thing and all those kind of things, then that definitely goes down to problem selection and solution, because actually you've got value. Like, for example, you've got I don't know, a bot, right? And what so that someone needs to interact with the bot, and that creates value. Now that you've selected that it needs to be a bot, and then further down you can also select the problem actually that it needs to reply to the person, but build I'm not gonna automate it. So you kind of constraining the problem further, and then the solution is simpler. So yes, in that way it can definitely help. Yeah.
Like, are we straying too much away from the original
No, no, I was just like trying to bring that
topic?
a bit closer to our day to day in terms of building software. And but I think that this discussion is important because I feel that we as an industry also we moved away from design, business analysis, even architecture, and in a way, like it's almost like, for example, oh, we should just like write some user stories. Let's start coding, and then we see where it gets us to. And this is for me like is a source of complexity as well because we are not analyzing the problem anymore, right? We are just going straight to a solution, and this is a problem. And when I talk about design and architecture, I'm not just talking about creating the diagram or the architecture itself, but in order for you to design or to architect, you need to think deeper. You need to analyze. You need to do a business analysis. You need to start asking questions. And I think that that process of that to create a direction, let's say, we should do more in our process. Going back and say, look, okay, I understand what you're trying to do, business people, but like, what are you really trying to achieve? Like, what about this, and that? Can we compromise on that, or what about that one? Is really discuss a bit deeper the what they are asking, and because as Mesh said, like in the hot water case, there are many ways that we can design a system or build a system. But if we invest a little bit more time in trying to analyze what actually needs to be done and the different constraints and the trade-offs, we might be able to come up with multiple solutions, multiple ways of building, and then choose one that is more appropriate. And I don't think that we do that very enough anymore.
Yeah, it's the whole area. It's like, yeah, business analysis, and in actually in design world, especially in kind of more traditional design worlds, I mean, this is problem analysis, and problem analysis was taught to us, at, like, I remember doing a lot of work on it at university time and so on as well, but we very rarely use it. You're right. There is this whole idea of kind of piecemeal backlog, and then building the next feature and the next feature, and not really questioning the solution as a whole, the product as a whole, what kind of things that is trying to solve. These things we don't do as much, and what happens is that we get complexity. But not only in the problem space. I mean, there are other aspects of accidental complexity we introduce, because and it's at all levels, right? It's at the practices level as well. So for example, like, talk about the kind of your testing landscape, right? We are doing testing because we're trying to solve a certain problem. Now we can just be very dogmatic and say, oh, all tests need to be at a particular level, or I need to test everything, or even I need to do testing development in all cases, or those kind of things. And what we don't realize is that these things, they actually reduce complexity, and there's pros and trade-offs, right? They reduce complexity in certain dimensions and increase complexity in other dimensions. And the same thing happens with our design choices in the software as well, and the technologies we use and the languages we use, and also. And I think this whole thing actually has this impact. And of course, then also what Jose mentioned at the beginning is that how we choose to organize ourselves is almost another dimension of complexity, right? And this whole communication problem, all the way from who actually owns the value or the problem, and who is solving it, and all the kind of this Chinese whispers effect that creates a lot more complexity, or accidental
Yeah.
complexity, let's say, behind that as well.
Maybe it's worth like taking some of those different sources of complexity, if you like, and then explore them. Maybe like start with a more technical one sometimes. For example, of course, that scale or size, like for example, the number of developers that you have will eventually create more complexity. But even when I was working alone, so many years ago, I tried to have my own product and startup, and I was alone building that. Yeah, and even then, on my own, I created complexity in the software. So we cannot only blame other people. That this is what I'm trying to say. But for example, I remember that I wanted to use. I can by heart try to remember a few things that led to a complex system where I was the only developer. The choice of frameworks, because I try to learn, and as I was starting from scratch anyway, so like why don't I just pick some things that I want to learn? And in doing so, of course, that you are trying to learn something, but you are not proficient at that, which means that you don't have the right skills. And even like the way that you design, Mashooq touched upon that earlier. For example, if you are using a paradigm style that you're very used to, like OO, and you go from Java to C Sharp, your design will probably look very similar, right? But if you go to a functional programming or a reactive approach, so, and you don't have those skills, like modeling in functional, for example, it will be very difficult. I would struggle with that myself if I were to do today. And so there was an element like complexity was introduced because I chose things that I wanted to learn at the same time that I was trying to deliver something. So I made a lot of mistakes, or I was playing with a lot, trying to figure out how those things would work. So of course that I introduced complexity. Another big source of complexity in my code was I was creating abstractions uh, to prevent problems that I would potentially have. Because in theory, if you think about it, you would just write a linear code. I need to go from A to B. I need to do this to work. So why don't you just write a procedural code, very linear, right? So hit to this page, needs to go to the database, right? It's very linear, no abstractions, no nothing. The reason that we start introducing all those abstractions and stuff is because we are trying to prevent certain problems to happen, including readability, right? So, or I want to make sure that things are more, I can reuse things, I avoid duplication, or if this area of the code changes, then I need to have some protection so I can change that area without having an impact on another area. So every time that we start introducing more structure in the code, it's always because we are trying to prevent a problem to happen in the future. And then depending of our biases or depending of the things that we don't want to happen or previous experiences, we will be creating certain structures in our code. And this is a source of
this is actually a very interesting topic on the dependencies between different parts of the software as a network graph, right? And so you can introduce abstractions that reduce that network graph or that increase it. So the way to look at it is that, if you have 10 elements, sorry, I might get a bit too kind of abstract again, but if you got 10 elements within the system that are all dependent on each other, you got the complexity of I think it's 2 to the power of 10, or the other way around, 2 to the power of 10. But actually, if you then are effectively able to divide it into 5 pieces that are talking to each other only, and the other 5 pieces that are talking to each other only, you get actually, I might be missing the formula, but you get a lot, you decrease, and then those 2 big things talking to each other just through a one network.
I think the formula I'm looking for is n times n minus 1 divided by 2.
Yeah, something. Yeah, but
okay. And then when you split it, and you get the same thing, but then you get a next between the other.
Exactly. So you get, basically what you get is you get a reduction of exponential reduction or increase in complexity based on whether you're introducing these 2 abstractions to reduce the network effect, right? And this basically, in a different way, defines good application of coupling and cohesion, right? Now, and for if you are introducing abstraction for those reasons, and they are effectively creating this phenomena, you are simplifying. And this, now we're talking about complexity in the solution domain. You are
Yeah,
simplifying complexity. But
yeah,
if
and it's
you,
funny.
sorry, go on.
No, no, no. Finish
But
yourself. Sorry, I
I was
thought you
just
were
going to say
done.
that if you do it badly, that you can actually compound complexity, right? Where, especially when you have uh, places that are distant but still have that network effect. So not only now you have this network effect and complexity, you've also lost cohesion, which basically means that now you have dependency at a distance or unknown, and so you lost cohesion as well. So creating uh, an abstraction that's not well thought out can actually compound the complexity, and if it's well thought out, can reduce complexity. So that's another thing. I think
Yeah,
abstractions in themselves are not wrong, they are always bad. It's just how we apply them as well.
this is the thing. I don't remember where is this from, but the whole thing about architecture, basically minimizing. So good architectural decisions would help you minimize the kind of trade-offs that you need to do later on. So they would delay it as much as possible, having to introduce complexity, so to speak, to what you're doing. But you're making those decisions since the beginning, right? Like the
Mhm.
minute that you choose a stack or whatever other technology you're gonna be using, if you don't understand well enough the problem, but you're still applying sort of like a class of solution, like microservices, for instance, people who don't understand the problem and then tend to apply a solution that may not be very well fit for this. All of this is already creating that complexity, or added complexity
It's
that we're talking about as well.
what you're talking about and what Sandro talked about earlier as well. Actually, it's referred to as impedance mismatch, right? So impedance mismatch is defined by where the technology that you've chosen is is not suitable to directly suitable to the problem or the design. So what happens is that now you have to jump through hoops, and you're adding accidental complexity. So a typical example is taking, for example, a JSON data structure and applying that in Java in an object-oriented language, right? Um, they have an impedance mismatch. So what you end up doing is you parse them, you put them in objects,
You use C sharp.
you
That's-
work you
Yeah, I needed
work with
to.
them. I don't know, my even knowledge of Java is old, so maybe Java now has a whiz bang framework, which I seriously doubt. But I'm just kind of hedging my bets. But you get this impedance mismatch, and because of that, now you have all this translation complexity from one representation to another, right? So for example, not that I am advocating JavaScript, but let's say JSON has an impedance match with JavaScript and a JSON store, right? So when things are coming, and you don't have to do a lot of translation because JavaScript natively handles it, JSON store natively handles it. In the front web page, you've got you dealing with exactly the same. You don't have the translation layers, and so you've reduced the accidental complexity.
Yeah, I was just like trying to go back to a point I made. I just remembered 'cause YouTube doesn't allow us to share links on the chat, by the way. Uh, but I wrote a blog post a long time ago called Inflection Point. If people look for Inflection Point and my name, they will find a blog on Codurance. And I was talking about uh, as we are writing code, we try to optimize for future problems, and I call it future proof. So how future proof do I want to make my code? Yeah, and those future proof can be from many different aspects. As I said, it can be even be things that are more difficult to measure, like readability or maintainability and stuff. But it can even be like, for example, performance, security, and stuff like that. So we are. I'm preparing my code, so not only to do what it needs to do, but I'm doing that in a way so that in the future it will be easier to be maintained by someone, or to have low impact. If I change here, it doesn't break something else, or something, right? So it's fast and so on and so forth, right? So and there is I think that you can introduce complexity going in each one of those extremes, right? Because a lot of people, mainly in the agile world, like it's like, well, don't introduce complexity if you don't need, yeah. Because I think that even I think that Laura or Laura mentioned that like sometimes she missed the waterfall. It's a bit related to that because I think that in the past, in the waterfall times, because I lived through that period myself.
What do you mean the waterfall times? That still is a
It's
thing.
still
There are
right.
still
Okay,
places where
so
that is done. Yeah.
but I think that like back then, the design phase or the planning phase, we were trying to do that because we were doing all of that up front. We were already built into the solution. Not only the simplest thing could possibly work, but also like we were trying to cater for multiple people maintaining that or future evolutions, and because we didn't know in which direction the system would evolve, we would end up putting abstractions everywhere, because then whichever way the system evolved, that area we would be protected, but we would be paying the price of a more complex structure across many other areas that we would not evolve beyond the original idea. On the more agile way of working, we almost flip that around, right? So like, okay, let's do the simplest thing could possibly work, and we introduce abstractions and complexity when those things evolve or we need a variation in there. And this is what I call the inflection point. I think that if you just everything we do is too simplistic, everything else we do afterwards will need rework on whatever we have. But if we also try to cater for all possible changes that we cannot even foresee right now, we will introduce abstractions everywhere, and then we pay a hefty price on complexity without a real need for that. But there is, I think that mainly at architectural level, there is an inflection point. I don't think that you can, as we said in previous episodes, that you could just say, oh, you know what, let's start writing a few classes in here and expect an enterprise system to emerge. So there is a minimum level of business analysis, technical analysis, architecture, design, and a set of problems that we should take into account from the beginning or the early days of the development. Because if we go for a very simplistic approach, we know that you're going to be doing a lot of rework as well. But so this is what I call the inflection point. There is a point where beyond that point, you have problems, right?
You're making it more. You're making it more complex than it needs to be for yourself. No, this is
Yeah,
the idea. So
I think that
again,
there is a
this for
degree
me
of
relates to the.
problems. Sorry, a
For
different
me,
way to put that. A different way to put that. Just there is a degree of problems or certain type of problems that is worth addressing from a bit earlier on, because you have a good degree of confidence that you will need to address them anyway, and it will be better that they are certain things are factored into your solution from the beginning, instead of trying to shoehorn security or monitoring when the application
listen.
is already quite far away.
Sorry to go back to this. Yeah, but for me, again, it kind of goes back a little bit to the Ginefin framework and all of this, right? Because the Ginefin framework talks about this four kind of types of context and how to deal with those, right? Then simplicity, no, or a context where you have these steps very well defined. No, like this is what needs to be done. All of the variables, or at least most of the variables, are very well known, and you can optimize and get the best result possible. That's one way of that's one place. But then you have things that are, I think, the distinction that it makes between complicated and complex and chaotic, right? Which is mostly where we move in software development, is quite right, like because you have in a complicated environment, you have some knowns, yeah, you know some variables, and there is certain level of predictability that you can get, right? Like you know that you can get a good result if you do that thinking, right, and really understand the problems and all. In a complex environment, that is not the case. In the complex environment, there's a lot of uh, again uncertainties, that you don't have. You have too many variables. You have like this kind of stuff, right? Like, we're doing a lot of that pre-planning is not going to help you get there, and it's easier to, well, not easier but more effective, let's say, to navigate that context differently than just doing some design up front, or doing some of this stuff. And this is where a lot of the agile approach you know comes in handy, if you are using it properly. And then you have chaos, right, where nobody knows what's going to happen. You just act and then see what you get from that, right? Like there's no point in making predictions of how that's going to work, and then you just
I
adapt to the context as it's happening, right? And I feel like that this kind of fits to that, no, like for me, waterfall in a lot of cases is using the wrong approach for the context in which you are working, right?
I think I think it does and it doesn't. There are two elements to this. For me, the Kneffen framework is more related to dealing with essential complexity. So when you have highly complex essential complexity versus complicated, or that kind of thing, where the levels of essential complexity are high or low and so on, and the kind of strategy that you can apply to the inflection point, to me, actually is more about the trade-offs you're making in terms of the material that you're using to evolve your system. So from for what the way I understand it is that when you're talking about upfront analysis, upfront design on paper and so on, to me they are more malleable materials, right? And code itself is less malleable. It's less able to evolve than a diagram on a Miro board or on a whiteboard, right? when when you are evolving something that is fairly undefined, or you're still exploring ideas, it's better to explore them in more malleable materials than in more than less malleable materials. So you know making this, if you're using boxes and arrows for your classes and
Yeah, the
interactions and
cost
so
of
on.
change. You're trying to reduce the cost of change
Exactly,
and
and
all
you're
that. Yeah.
evolving. Yeah, so boxes and arrows help you, they encourage you to evolve, whereas code less so, because you
Yeah,
have to do a lot of lifting and shifting, and you end up not evolving it to the point that it needs to be, because you have inertia. There is too much there for you to evolve to the ideal position that represents your new knowledge.
and I believe that what you are referring to is that, of course, that we are not evolving the actual software itself while we are using more malleable materials like whiteboard or box and arrows. But what we are doing there, we are exploring the possible solutions and the problem domain, right? So this is what we are
Exactly.
doing. So we are
And
making
even
it
the solution
cheaper.
domain. Yeah.
Yeah.
Even in
So we are
some
making
cases
it
solution,
cheaper to
because
explore.
yeah. It's even with the solution, like when you're talking about classes and and objects and those kind of things and components and so on, putting them on a board and kind of playing with them and seeing how they fit, and using different perspectives, like interactions and structures and all those kind of things. And this all helps you to evolve, understand your problem better, and understand your solution better. And in fact, often when you're doing problem analysis, you have to deep delve into the solution to feedback into the problem. So you have to take these fast feedbacks, and like a drawing on a board or a thing is much quicker feedback than writing the code. But
Mhm.
by the way, this question around the AI, I think, Sandro, you asked like what you mean by the AI. I have something to say about
Mhm.
this. Do you think that the question is from Salva Crespo? Do you think that this complexity may be the reason for projects like Google to promote AI programming for us? I think Google promoting AI programming is about easiness and not complexity. And I'll give you an anecdote. Right, when I was doing my bachelor's degree, one of the modules was neural networks, right? And the way you build neural networks is that in them days they were kind of hardware related, and the way that you build them is through these learning algorithms like weighting, and you have these kind of small elements, and then you weight them. There's input, outputs, and a weight, and the weight is changed in order to get to kind of meet the sample results. So that's how the neural net learns. And you can never, very rarely, see how the neural net is performing the task that you've told it. It will do it, and it will do it well after a lot of training, but often you don't know how it's doing it. And so actually that's what I mean by easy and simplicity. A neural network is complex, and like generative solutions are complex. They are not adhering to simplicity from the point of the reader. You can't, like, things that are generated often are very difficult to read, and especially when AI programming is working and creating code that's not created by human being, it's going to start making certain optimizations that are no longer for the domain of the human being. In that's the anecdote in those neural networks we were training, was that we were often kind of told to do a small thing and then try to see how it's doing it. And one of the things, actually, they found out that it was using a short circuit within one of the chips in one of the machines that you're using to present logic. So it knew that there was a flaw in the motherboard, and it was using the motherboard's flaw as part of the solution. And it took us ages to get to why it's doing that. It was such a small problem. But that goes back to the thing that when computers are creating code, and then you are intending to read that code or update it, you've got a world of problems. You're actually introducing a lot more complexity. So the question on whether Google is doing the AI programming to solve this complexity for us, no, they're actually making things more complex. They might be making it easier to develop software, but for you to then maintain it as a human being, you can forget about it, especially when you talk about larger systems.
There is another question that I would like to address. Is one from Dirk. So he asks, like, what qualities do people need to have? What qualities do people need to have a good feeling for the future evolution? So a good balance between Yagni, or you ain't gonna need it, and over engineering can be achieved. This is a very good question, Dirk. So the way that I like to think about this is back to what Mashooq was saying before, is making sure that we define the problem well. So and defining the problem well includes some even quality metrics, if you like, as well. So for example, we can define the problem in one way that says, hey, we need to implement this feature for our clients. This is one aspect of what needs to be done, right? So, but we still need to define the scope of that problem domain. How are we planning to achieve that? How do you want to maintain that? What are, for example, do you want how many clients are going to use that simultaneously? While we're building this feature, are we going to build many other features in parallel? What is the size of our development team? Do you want to deploy this feature separately from other features in the system? To which degree do we want full automation of those of this feature in terms of testing and deployment and so on? So all of that are things that we might be optimizing, or these become part of the problem domain and the solution space as well. So, for example, do we want to follow a similar pattern for other features, which means that we are aiming for familiarity, easy to read, because you're following standards that you already have in the code, or we are exploring that in a completely different language and stuff. So there are many things in there that we need to consider. I think we should settle for some of them. For example, in order to build this feature, we need this minimum set of testing, automation, or security, or monitoring and stuff like that, because you are putting all of those things, but that needs to be agreed with a wider audience, like with the rest of your team or across teams or whatever. What is the solution space, right? So we know what the problem, what we're trying to achieve. So there is a problem domain, but what would be the size of that, the shape of that solution that we want to give? And some of those things we will factor in from the beginning. So I normally like to factor in some operational requirements that we call it today. In the past, we used to call it non-functional requirements, right? So today, I think that a better term is operational requirements. But like
Or
security,
cross-functional,
scalability,
some call it cross-functional as well.
yeah, or some people call, those things for me, they are part of your solution.
The cat has a
I'm
lot to
sorry, guys.
say
She has an
about this.
opinion. She has an opinion, and she wants to tell you. No,
but
I
I
have
think
a.
that's how I would say, Dirk. So like, sorry, I think that you need to have a certain set of standards that would fit within a solution, and then you can factor in from the get-go.
I have a different angle to that, right? Because he's asking about what kind of qualities no or no, and I think in the end that is about doing trade-offs. How much do you do, right? Like there's a, let's say there's an ideal solution to this thing, and then there is many intermediate steps that you have from where you are, right? And I think one quality, or at least one thing that I would expect, is for people to know what are the pros and cons of all of those intermediate steps or different solutions, so that they can have enough information to make that trade-off. So experience is a big factor in that. Having seen it firsthand is a good way of understanding what the pros and cons are, because you suffered through them. No, but also, if you haven't had that experience, you can still go and look out for other ways of doing it. This is where katas and other, doing some other exercises that may not be production kind of related will also help you. But the important thing for me here is to understand that there are many ways, what the whole spectrum is. What are the different possibilities? Whether you like them or not is not that important, in my opinion. You can have some. I personally wouldn't. I would prefer not to have them, no, because in the end you're trying to solve a problem that will get in the way of doing the right trade-off. If the minute that you have a preference, then you have kind of like a weakness on making those trade-offs. But the idea is to know as much about all the other solutions and the alternatives to that, and being able to compare and choose where, because you're always so that's one aspect. The other aspect of that is understanding what you're trying to achieve, like what is the value, that you're trying to achieve. And then the other aspect is what are the constraints, understanding the constraints within which you're working, right? So you have those three things, like what value you're trying to, what kind of solution or the solution space, and then what constraints, then you can understand how to make those trade-offs. Now that's not very easy to do. The cat, that's not very easy to do, right? But I think that's the essence of it. If you only have two things to choose from, forget about it. No, it's like you either do one or do the other. No, if you only have one thing to do, this is a lot of the time. This is what happens. Like people are dogmatic about what they, the tooling and the way that they approach things. Then you're not going to be able to make those trade-offs, right? So that's the way that I see it.
There was like I wrote that blog post again, like people can search the inflection point and my name, and you'll find it in the Codurance website. It's quite an old blog post. I evolved that, but I never wrote about that the evolution, because I had a picture that was I had, like, for example, the picture was like a spectrum where you have this straightforward. For example, you have something to solve, you just do enough code to solve that. That's the simplest thing could possibly work without taking into account the bare minimum that you need just to get that done. As soon as you start factoring in other things that I call future proof, that's when you start evolving that there is a trade-off. So for example, if I'm going to try to future-proof my code to something, I'm not only trying to solve that problem, but I'm also trying to prevent a problem, right? So there is a focus on solving the existing problem, but also preventing other problems to happen. The problem with future-proof is that you can try to future-proof your code across multiple things, right? So it's not that it's just one thing that you're going to try to future-proof. And this is where the complexity really is grows, because you're trying to future-proof across multiple areas. And then, so there was a line underneath this graph of the straightforward to multiple different types of future-proof code, and there was this line was a trade-offs. So this is the kind of trade-offs that you make. If I want to future-proof my code to a bunch of stuff, I might be trading off simplicity and even the speed of delivery as well, time to market and stuff like that. But if I try to just the trade-off is like I will focus on time to market, simplicity. I would be potentially sacrificing potential problems that I might have. But there was also the thing that is not in the blog that I added was a time element to it as well, because those things, they change over time, right? As time goes by, those trade-offs, they also have an impact, right? Because certain windows that you have, the window of opportunity, if you like, they start closing, you know? So that it's a bit more, so finding that inflection point and going back to Dirk, the kind of calls that people need to have is very complicated, but you need to have that holistic view and be able to make those decisions consciously.
Should we go into solutions a little bit, or some recommendations on how to reduce this accidental complexity?
Yeah. There are, it depends. We were, first of all, on a more technical side, I think that one way to avoid that, Laura, I would not say to go all the way back to waterfall, but I get your sentiment. I don't know if it's Laura or Laura. But I think that the sentiment that you wrote, if I understood correctly, is we need to invest more time in planning, not planning, but analyzing the problem
analysis, and even analysis and solution exploration.
Yeah,
these are the two things that we do very little of, and I think this is definitely an area. But I would also say that when you are applying anything, you need to think very carefully, right? And I was giving an example of a particular language. Like often as software developers and even as companies, we will stick with a single language. For example, different languages have different kind of strengths, and understanding and creating a toolbox where you understand how those different languages, and that's just one area. And this goes back to Jose's point. If you have one solution to choose from, right, it's not gonna always fit every single problem, right? Not everything is a nail if you have a hammer, contrary to popular belief. But the same goes for
It looks like a nail. It might not be, but to you, it looks like it.
Exactly. And often we put too much emphasis on our fluency with a particular paradigm and a language than whether that paradigm or language fits the purpose, right? So that's one area. The other area is also the kind of the certain kind of solutions that we choose, frameworks and so on. They can introduce complexity, they can reduce complexity, they can help or hinder. The design choices that you make will help and hinder. The practices that you choose will help and hinder. But if you have a dogmatic approach to practices, to solutions, to languages and all those things, you're going to get it wrong quite a lot of times, because if you getting it right is just an element of luck, right? Because you only have that particular way of doing things. So exploration of all the different solutions, understanding the tools, is actually part of our professional responsibility, in my view.
I'm gonna risk to say something. We even had a fireside chat quite an old one. I don't know exactly how far back. I would need to look at our history, but like there was a fireside chat that we had about coupling and cohesion, if I'm not wrong. And we applied coupling and cohesion at all levels, not only in software, but in organizational structure as well. I still believe that although we can talk about accidental complexity coming from multiple areas, it can be technical, people, process, all that kind of stuff, I would risk to say that when you think about coupling and cohesion, it's a way, because now we are talking about how can we reduce complexity, right? That's the theme. So I believe that taking the concept of coupling and cohesion to a much wider scope, as we discussed in a previous episode. And what do we mean by that? For example, when we analyze the patterns of communication, everything that has a high bandwidth of communication, you keep together, but you try to break those groups as much as you can, so that there are a lot of different groups, and within each groups there is elements that communicate a lot among them, but you create a very well established communication pattern across those different groups, which means that you have a highly cohesive group that is loose coupled from other groups. And loose coupled means they have a very well defined and single channel of communication. So when you take this concept
and changing
to
one doesn't
multiple,
impact the other.
exactly, and changing one doesn't impact the other, or the impact is very limited to that protocol of communication, right? Being an API or just a way that departments talk to each other or coordinate work. So I think that there is a general concept to avoid or reduce complexity is to think about coupling and cohesion this way. For your processes, for your groups of people, for your software modules or systems, everything. I think this is a good guideline, I
This
would
is,
say.
yeah, that is definitely, yeah, that it's a strategy for reducing the communication complexity that we talked about, right? And
And the
that is
impact of
whether that's
change,
communication between people or communication between software components and different pieces of software. Yeah. So but I
impact
think,
of change and easy to
yeah,
evolve without breaking others and so on. Right?
exactly. So I think that it's definitely that strategy for that, but I would say that, yeah, it's one of the strategies for reducing complexity. But complexity comes, as you said, in other forms as well, where you will need to think about other things as well, like, the problem selection we talked about, tool selection we talked about. There's a lot of different things that bring in accidental complexity
There's
into
one
the
thing.
software process.
There's one approach as well that I think we haven't mentioned, or at least not that I remember. But approaching software building as growing software, I think, is another thing that kind of tends to reduce the complexity. And what I mean by that is things like walking skeletons and this kind of stuff, where you start with almost nothing but a general view of your system, and then continuously incrementally introduce more of those specs, or more of the value, the lever that you want to do. And that kind of forces you to start with almost nothing, yeah, and then add layers on top as you need them. So everything that you are doing is kind of justified, because again, it's needed in order to add the new value that you're adding. And that way, you don't necessarily go into a lot of over engineering or over architecting and so on. So I think that is a good way, let's say, systematic approach, so to speak, not to try to keep that in check. Yeah.
I think
Yeah.
I totally agree with you, but I think it's easier said than done. It's
Yeah.
because when we talk about growing software, what you're talking about is doing the simplest thing at every given step, right?
Yeah.
And I've seen a lot of
The
people where people think
mantra.
that the walking skeleton is a skeleton, but it's a very, very complicated skeleton. It's like they've introduced all the the technologies and things that they like already in there. And but yes, I think in principle, when you talk about growth, you talk about very simple incremental steps, and each one that has value in itself. um, but yeah, it's again, it goes back to that whole thing, like, people have built skeleton where they have 20 microservices.
Yeah,
Each
that's
one is not doing a lot,
it.
but that's their skeleton, and that's not really growing from the simplest steps, right?
Yeah, no,
Yeah,
there's someone in the chat, Artemas, I think, it says sometimes always asking, do we need this now, is also key to avoid complexity and unnecessary dependencies. Yes, definitely. That's part of of reaching that simplicity, right? Like, can you remove the minute that you cannot remove it because otherwise it doesn't work, then you've reached that
Yeah,
kind of level
yeah.
of simplicity that you're looking for, right?
That goes
uh
back to the original definition of
yeah,
accidental
yeah, yeah.
versus
I think,
local,
by the
right?
way, I think this is, if I'm
uh,
not mistaken, this I think in the Little Prince book, there's something about this. I will look it up, because I think there is some sort of quote, I think, from Saint
mm,
Exupéry that is related to simplicity as well. I'll look it
yeah,
up.
yeah. There is one
okay.
thing that I would like to add because I saw. I think that is Artemas. Apologies if I'm not pronouncing your name correctly. Uh, that in general, yes, I would say I would agree as a general principle. Say, hey, do we need this now? In general, I would agree with this principle. However, uh, I also this is what I was talking about, the trade-offs and the straightforward to future proof and stuff. If we are always just focusing, the problem that I would have with this approach sometimes is that this approach might lead us to a very myopic view of the problem. For example, you are not only building as one feature, right? We are building a full-blown software over time. But if everything we do, we just have a very narrow view, it's like, what is the bare minimum that we need to implement this? We gradually start creating a Frankenstein as well. And at some point, you see teams that are now, everything that they want to do, they go through a very large cycles of refactoring all the time, or they need almost like they are brought to a halt because now they need to refactor loads of things because they cannot, because they didn't build some of the abstractions, or they didn't care. For example, a sequential, a large sequence of doing the bare minimum that we need right now for each one of those features very rarely would lead you to a more strategic view of your software in how you're building, how you're growing, how many people are working on it, how you're maintaining and stuff like that. And this is for me, the other extreme. We just need to be careful. Artemas, I'm by no means I'm suggesting that that's what you've done, because like before I saw your last message, one of the questions that I would have from your first message is, for example, you mentioned that the team would choose the simplest solution. What would be interesting to discuss is what did you factor in within the simplest solution? Is it just getting the job done for that feature, or you factor in other things as well that leads more to the strategic side and future proof as part of the simplest thing or the smallest thing that you should build? This is
it's
where I
it's
think that
it's
the
it's actually funny
challenge
because
is.
the word growing is very weighty, like growing software, so that at every increment it grows, right? Like you often see sometimes like that agile picture where they say, well, a solution is a skateboard, and then a bicycle, and then this and that, right? And actually, if you follow
I
that,
hate that picture, by the
yeah,
way.
exactly. If you follow that metaphor, basically means that you're throwing your solution out of the door at every increment, right? Because a
Exactly.
skateboard cannot
Exactly.
just turn into a bicycle,
Exactly.
right? Then there is another metaphor that people talk about, which I find quite compelling, but again has its own problems. Metaphors generally do, and it's the growing again, but like growing the way that a plant grows, right? From a seed, at every single point, it's a plant. Even that little sapling is very simple, but it's a plant. But all the way to a tree, is the same thing. It grew, right? And at every step, it was a complete thing. It was always a plant or a tree or whatever, right? But then those kind of solutions have a fractal nature to them, right? The way they grow. And software doesn't always, often, most cases, is not fractal. It's not that simplistic a structure. So I think the word growing can sound quite nice. Sorry, Jose. Can sound quite nice and idealistic,
It's
but
fine.
in the real world, there are problems with growing systems.
Yeah,
Yeah,
for sure, for sure.
yeah.
I wasn't again. It's not a silver bullet. Yeah,
Mhm,
it's just
mhm,
if you need some guidance on how to approach this, those could be ways to the rule of thumbs that work for 90% of the cases, not necessarily for 100% of the cases, right?
mhm.
And again, it's also as I go back to the experience and knowing more than one context and all of these things, so that you can choose whether that is the right approach or not for what you're trying to do. Like before, when you were discussing this, it's evident, no? Like it's a little bit like when you do when you're first learning TD, and it's like, no, do the simplest thing that works and whatever, right? Oh, let's hard code this value here. No, and now we're gonna hard code this value again and hard code, and then at some point you really need to say, hey, this is not working out, right? Like I
Exactly.
may end up making all the tests pass, and I know you want, but I'm not
Not
delivering
building
the
anything.
value. I'm not
I'm
building
building a
something, right?
database table.
Exactly. No, this
That
is
might
like
be
the other day I
your
saw on Twitter like a method that is odd, is odd, no, for a number, and then
yeah.
anyway, if one,
This one is two is three.
exactly, right. And it was a bunch of ifs, one after the other, right? So that's
Like
it's the same thing. Like you can easily go into that area, but for me, that would also the not kind of not understanding the context that, and I go back to the definition that I said about being pragmatic, because this is something, pragmatism is one of the values that we have. So I've been thinking about this and how to explain to people as well, right? So and understanding the context, not only the value that you're trying to, but understanding the context and the constraints. And there's always a constraint: time, money, and so those are very hard constraints that every project, independently if you're a consulting business or a product business, you have, right? And if
yeah,
you're not taking those things into consideration, then you're
yeah,
not doing your job entirely well as you could, let's say,
yeah,
right?
exactly. Mm,
So that's part of the thing, right?
yeah, yeah. Okay, so we're gonna close. We've already 7 minutes over time. So any final thoughts? Let's keep it fairly short.
No, I think that the for me, like the takeaways is that try to simplify the problem and explore the solution, explore multiple solutions. So the sooner, and do that in the cheapest way possible. So probably not through code. And so that is one side. Another side is considering the coupling and cohesion across multiple levels. Keep everything that has a strong dependency and high communication frequency together, and try to split in as many different groups as possible, and define a well-defined communication across them. So that's some of the takeaways from my side.
Thank you. And Jose?
I more than a takeaway, maybe a recommendation. I would suggest people to take a look at No Silver Bullet, the essay by Fred Brooks, which, by the way, recently died.
Mm-hmm.
So, uh, you know, rest in peace and all that. So take a look, because he talks about accidental complexity. He talks about design. He talks about how what kind of his thoughts on many of these things, and that I think are still quite relevant. This was a suggestion actually by Mash, so so please go and take a look. I think that that would be helpful in understanding this, and also take a look at Kinefin, the framework, and there's a lot of stuff out there around this. So yeah, take it out. I think it would help, you know, expand the horizon when you're thinking about complexity in software as well.
Thank you, Jose. And mine is a simple one as well, is that actually as software developers, we need to be aware of what is accidental and what is essential complexity, and that will help you in creating simpler, better solutions. So just having that awareness, always keeping that in mind, is already quite a way into reducing complexity. Okay, well, thank you everyone for listening. As usual, please subscribe and like if you want to be notified for our next. It's usually every Tuesday evening around 7 o'clock UK time. And yeah, leave us comments as well, any encouraging thoughts and everything, and join us in the next live session as well if you can. And give us ideas of different topics as well. You know, we are always looking for things to discuss. So if you have anything good in mind, then send us that via Twitter or comments or email. So thank you very much for listening, and it's a goodbye from us.
Thank you all.
Bye-bye.
Bye.